All right, hello Programming 12. We're going to be talking about the hero class now. That extends our game object class. In the previous lesson, we made the game object class as our foundation. So now we're extending it, and we're going to be building upon that foundation. So just a reminder that the hero class will get everything that's in the game object class. So for example, it's going to get a location vector, a velocity vector, and a hit point int. So that'll be helpful. And we're going to add a couple of things onto it, 3 things. We're going to add a speed variable, and then this room x and room y int. The speed variable I'm strongly considering adding to the game object class. I'm very strongly considering it, so stay tuned. I might move it over. I think just a lot of things will have a speed, and the reason why I want to keep track of the speed separate from the velocity is that velocity kind of represent the actual speed at which I'm walking and what direction I'm walking. So that's velocity. That will be the thing that moves me around the screen. Whereas speed is going to be sort of a maximum. It'll tell me how fast I can go, at, a limit, if you will. So this is a good thing to have as a variable because you can imagine your character might get faster as the game goes on. Maybe you'll find new items that will improve your speed, boots of fast walking or something like that. Also, there might be some status effects in the game that lower your speed. Maybe you are fighting an ice monster and it freezes you. So maybe you want to set the speed to a lower number. Maybe it, you get frozen in time for a short period of time. So maybe your speed gets set to 0. So that limit is a useful thing to have as a separate variable than velocity so that you can have that, updated as game effects apply to it. So speed is going to be right now for the hero, but I could see it being a useful thing for bullets, enemies, all sorts of things. So it might end up over in the game object. Room X and Room Y, those variables are going to be used to keep track of where we are in our map, which is going to be a lesson coming up soon. So our hero is going to be in a particular map, and I think that's basically a particular location in a map. So that's basically the story of what those variables are. We're going to kind of ignore them right now. We're not going to use them too much, but we'll come back to those in a future lesson and make them useful. Again, I'm wondering, should those be in game object? And I think we'll find out as we make our other game objects, things that extend game object. If we have room X and room Y in a lot of them, then I might move them over. So stay tuned and watch out for that. So here's our hero class. You're going to see me doing something slightly different than in the Asteroids project here. I'm using the super keyword. This is kind of like super.act that we had before. Basically, this is calling the constructor and saying, hey, constructor, can you do your constructor? Hey, superclass, can you do your constructor? So it's saying to game object, construct. So, it's just doing this default stuff. At some point, I might make another constructor in the game object class where I could send parameters, and that just saves me the trouble of typing this 3 lines of code in all of my bullets and enemies and all that kind of stuff. And later on, I think we'll also have a separate constructor so I can send parameters. So that's all that's doing. Super calls this. If you have this code in place of the super keyword, it effectively does the same. It's just not as dry. You can't reuse that code over and over again, and that can be kind of annoying. So I would suggest using the super keyword. I set 5 as my speed. It's not necessarily the best or worst speed. I'm just going to do it and go from there. And then my room X and room Y I'm going to set to 1 and 1. On the map, which we'll see later, that'll be sort of our starting location. It doesn't have to be, but that's a good place to start. Okay, so that's the constructor for hero. Let's take a look at the show function. Very simple, actually. I'm just drawing a circle at the location, and I am filling it with a particular, value and stroke weight and so on. I think it might be nice to give it a direction it's facing. So I think we might improve that in this video. I might give it a little bit of a, I don't know, something to show what way it's actually facing. I think that would be helpful. And then here's my act function. So the act function is basically me calling super.act. So that means that in the game object class, this is happening. So the first thing that a hero does is, with super.act, it will move. So whatever its velocity is, it'll apply to its location, and then it'll check to see if it's hitting the walls. And then after it's done those, basic activities that every game object does, then I can add on additional stuff. So for example, I can put in some code for checking for the different key presses. So pressing the different keys, and these are all hooked up, by the way, to the key pressed and key released functions that we have seen before in the past. So that's going to be us sort of adjusting our velocity. Notice that I'm using velocity.x and velocity.y as opposed to adding to the velocity or something. The reason is because I want it to literally go straight up, straight down, straight left, straight right. So this is kind of like Vx and Vy stuff we used to do. I'm just setting these values. If I press W, I'm going to the left. No, sorry, I'm going up. I had to think about that. So I'm going to change velocity y to a negative value, so it'll make us rise up, and so on. This is just basically the same as what we used to do before. You might even wonder, well, what's the point of using velocity if we're just going to use the straight up old-fashioned Vx and Vy code? Well, it's still useful. I'll show you in a second how we can make that useful still, and there'll be other reasons too. So anyways, that's going to be our movement code. In addition, we have to stop. So I basically say if I'm not pressing W and I'm not pressing S, we'll set our velocity in the Y direction to 0. And if we're not pressing the left or right keys, then I'll set my X velocity to 0. So there's a couple of improvements, and if I just run this, you can see what's going on here. So here's our game, and I'm able to move left, right, up, and down. And there's no specific direction this character is facing right now, so that's not great. Not a big deal. But I'm just kind of moving in those directions. I can press both at the same time, and that's fine. You'll notice though, if I press diagonal, do you notice how I go faster? If I'm moving diagonally, I'm going faster than if I'm going up and down, left and right. It might not be super obvious, but the reason's because if I am pressing, let's say I'm pressing left and up, then I'm getting both X and Y will be set to 5. And the hypotenuse of a 5 by 5 triangle, that's greater than 5, right? So we're actually going to be moving faster than 5 if we allow this kind of code. It's not a big deal, and most people won't notice it. But if that bothers you, if you want to make sure you're literally going 5 in every direction, it's pretty easy to fix with vectors. And it wasn't easy to fix before with Vx and Vy. So basically, you can just make sure your magnitude of that vector is always 5. So I can say something like, hey, if velocity's magnitude is greater than 5, then I can set my magnitude to 5. And I probably shouldn't use 5. I should probably use speed, because that might change. So if my speed suddenly is impacted, lowered or something, then this will sort of force it to be lower as well. So I can have this nice little if statement. I don't know if I might put that on a separate line. Not too sure. So now, no matter what direction I go, it's the exact same speed. And this looks better. Well, to me anyways. I don't know if you can see the difference, but it does make the movement more realistic and make more sense. So I'm going to keep that in there, and I think that's a good thing for you to add in as well. For this code here, we're just kind of immediately stopping as soon as we release the keys. If you'd rather kind of glide to a halt a little bit, then instead of just setting y to 0, what we can do is we can multiply it by some fraction that's between 0 and 1. So I can set, instead of saying 0, I can say velocity.y equals velocity.y times 0. I'll put 0.9 as an example. So we'll kind of glide to a halt as the y velocity is repeatedly multiplied by 9. We'll kind of take 10% of 10% of 10% every frame. So we'll see what that looks like. So if I press up and release, you can see it kind of glides to a halt, right? Left and right still stops on a dime, as they say. But now up and down kind of glides to a halt. You still run into the wall just fine because that code is still running. So you can decide what your preference is. I kind of like this, but that 0.9 makes me glide a little too much. So I might change it for this game to 0.75 or something like that. The reason why you wouldn't have it so high is because this game is going to be a lot about dodging. So if you're, always sliding to a halt, then you're going to slide into a lot of bullets. So this one at 0.75, sorry, it's kind of lagging. It's a little bit smoother, and I think you can see that we're just kind of glide a little bit to the halt. Like it's just a little bit of softness in the stopping, which I think looks pretty good. All right, so that's basically it. There's more code for this, so it has to do with the room itself. So we'll look at that in another video. And yeah, we'll think about, maybe we'll think about the show function too. We might come back to that and think, well, how can I get it to sort of aim in a particular direction? Right now we just have the kind of the movement going on. So we'll come back to that. Okay, thanks, Programming 12. I hope you enjoyed the video, and we'll talk to you soon.